Good morning to one and all present here. The worthy patrons of the event, Professor R.C. Singh, Honorary Professor GNDO Amritsar, Professor M.P.S. Saini, GNDO Amritsar, Speaker of the Day, Dr. Ramendra Sundar De, Scientist D, INST Mohali, Dr. Pooja Devi, Core Committee Member, INYAS, Dr. Binia Arora, President Prayas, Mr. Yatin Batra, General Secretary Prayas, members of the Prayas and INYAS team, and the registered participants. A very healthy and beautiful morning to one and all virtually present here. I, Rajesh, Vice President of Prayas, would like to extend my warm wishes on behalf of the joint collaboration of Prayas, which is Progressive Regional Association of Youth for Advancement of Sciences, and INYAS, which is Indian National Young Academy of Science. I welcome you all to the program entitled Teach for Science, which is 2-month online fellowship event. You may already know from the previous week that the fellowship tenure includes expert lectures, project work, report writing, oral presentation, and many more. Fellowship will be awarded in 2 categories, classifying projects for UG/PG students and school students. More details regarding various categories can be found on the website. Today, we are going to start the first lecture from the expert lecture series. So, dear participants, it gives me immense pleasure to introduce Dr. Ramendra Sundar De, which is one of the distinguished researcher in the field of electrochemistry of nanomaterials. He is currently working as a scientist at the Institute of National Nanoscience and Technology, INST Mohali. After the completion of his PhD from IIT Kharagpur, he was awarded with H.C. Ørsted and Marie Curie Co-Fund Postdoc Fellowship at the Technical University of Denmark from 2013 to 2015. In 2015, he was appointed as a Scientist B at INST Mohali and was promoted as Scientist C in 2019 and eventually Scientist D in 2022. The prime research interest of Dr. De is around the study of nanocarbon-based hybrid material for the state-of-the-art energy storage and convergence system for renewable energy generation. His research group is in the progress of developing a hybrid supercapacitor with battery or biofuel cell for clean and self-sustainable energy storage devices, paper-based biofuel cells, and electrochemical study of nanoporous materials. He has published numerous publications in reputed international journals along with 3 patents. Presently, Dr. De is a member of multiple professional bodies, namely ACS, International Society of Electrochemistry, Indian Academy of Sciences, INYAS, and Indian Society for Electrochemical Chemistry. Also, he worked as an editor for an international journal. He has recently been honored for Journal of Material Chemistry, Emerging Investigator, under the theme highlighting 2019's Rising Stars of Material by RSC. So now I request Dr. Ramendra Sundar De to kindly deliver his talk on nanoscience and nanotechnology, role of electrochemistry. We welcome you, sir, in this platform.
Thank you for a very nice introduction. I could not share the slides showing host disabled participant screen sharing.
I'm promoting you to co-host, sir. Then you will be able to share it.
Yeah.
Sir, I have promoted you to co-host. Are you able to share it now?
Let me check. Yeah, I think, now it is possible. Can you see my slide?
Yes, it is visible.
Yeah, okay. Yeah. So, good morning, one and all. And First of all, I want to give thanks to Proyas and INYAS to give me this opportunity to deliver this lecture, and popular lecture, you can say. So basically, I'm from Institute of Nanoscience and Technology, Mohali. So many of you know, this is in Mohali at Sector 81, and we have beautiful campus. So if you are interested, you can contact me or visit to our institute. So we also do a lot of outreach lecture, and we reach people in a rural area and many places of northern India as well as overall India, different states, to make awareness of science and technology, mainly to our the children, school students, to give some idea about what are the going on in the current scenario in case of nanoscience and nanotechnology. So first of all, I want to give thanks to my students, my collaborator, funding agency, to give fund and carry out research on nanoscience and nanotechnology. So to start with this, first I want to say, so basically I'm electrochemist, and we are doing a lot of electrochemistry with nanomaterials, you can say, mainly. So you know, electrochemistry has several applications in different fields. As you can see from this figure, so one can use electrochemistry as a tool for sensing of different material. You can use it for to measure the corrosion of the system. One can use this tool for organic synthesis, some industrial electrocatalysis, energy storage and conversion. So this is not all, but a few application, you can say, where you can use electrochemistry as a tool. So it has a very vast application, but in our group at INST Mohali, what we are doing using electrochemistry, we are focusing on supercapacitor, one of the energy storage system, metal layer battery, solid state battery. These three are energy storage system, and electrocatalysis of oxygen and nitrogen, biofuel cell and water electrolysis. So why we are doing all this thing? Excuse me. Because if you see the global scenario of clean and renewable energy system, so one diagram I have just presented here to give you a little bit idea where India stands at the moment. So this is a diagram of carbon content of electricity. So if you see the carbon content of electricity, what you are using, although this is a little bit old data, 2017-18 data, so still you can see we are using a lot of carbon content in the electricity. And that is one disadvantage, or you can say we have to move forward from this carbon content to this electricity. As less as possible carbon content we should use. That's why government of India have focused many, they have taken many initiative to reduce the carbon content in the electricity. Not only that, if you see the transport sector of global scenario, so energy intensity in the transport sector, so we are actually very far from the state of that countries. So you can see, so we are almost not using anything on the renewable energy perspective in the transport sector. So these few things actually motivate us to work on a renewable energy system based on electrochemistry. So as it is a outreach type of lecture, so first I'll begin with, for some school children or college students. So, you know, what is science? First, when you do research, how you'll do some new science. So the three questions one has to ask. 4 questions: what, why, how, and when. So if you have in mind you are doing something, and if you ask yourself what is going on in this system and why it is happening, how it is happening, and when. So if you ask these 4 questions, so you will have your answer in one day, and that is called science actually. But science and technology is 2 different things. So science is basically pure, and it does not necessarily have the application part. You can explore the basic things, what is going on in some system, that is called science. But technology is more applied than the basic things. So it has some practical application in the society or somewhere else or in the engineering field. So we used to call that technology. So first you have to do the basic science and try to apply it to some societal aspect or somewhere else, so that you can call it technology. So I'll start with this person. I think many of you know who is this. So this is a Swedish scientist, Alfred Nobel. I think all of you know. And why he's famous? So first of all, he is the inventor of dynamite. And so he is not only a very, a good scientist. So what he did, because of his saving money. So now, the Nobel Prize is given in different discipline. So now I'll come to this part. So, in India, so these are the great people who got Nobel Prize. This is not only from India, Indian origin also have included. So whoever have Indian origin got the Nobel Prize. So why we need to know all this name? Because that actually motivates us to do some great science, or to do something for the society, you can say. So not only have to do science, so you can also pursue something to do something better for the society. Now, another few name of great Indian scientists who got Bharat Ratna in science. So among them, Professor C.N. Rao is the living legend, I can say. So C.V. Raman, Abdul Kalam Azad, Jahangir Bhabha, Vikram Sarabhai, and C.N. Rao. So all of them got the Bharat Ratna in science. Now I will come to the till now. So all what I discussed about the Indian scenario. Now I'll come to the electrochemistry part. As the title says, so I'll give a little bit idea how you can use electrochemistry in nanoscience and technology, and mostly on energy. So what is the role of electrochemistry in nanoscience and technology? So if you do electrochemistry, so this is the Michael Faraday, we used to call father of electrochemistry. So one quote I want to mention here about Michael Faraday. So he used to say, "Do not think, please, that I was a deep thinker or was different in early development. So I was moving boy with a rich imagination." So that is his quote. So if you want to do some science, some new thing, so you need not be very intelligent or very deep thinker. What you need to do is the imagination. So if you ask yourself these 4 questions, what, why, how, and when, so you can do some great science. So another one, another 2%, without naming these 2% electrochemistry you cannot do. So those are John Daniel, and this is John Daniel, and this is Michael Faraday. So this is very old picture in a lab. They are doing the electrochemistry. Another 3% name to mention. One is Helmholtz, Goy, and Chapman. So these 3% are famous because they worked on double layer. Double layer, where we use double layer in case of capacitor. Okay. So before starting electrochemistry, you should know this famous 5 scientists name who have a significant role, or you can say the progress of electrochemistry. Now, another 3% names I want to mention here. One is John B. Goodenough, Stanley Whittingham, and Akira Yasuno. Can anybody say why these 3 name is very famous? And why? This is from very recent development. So, can anybody unmute yourself and can say why I'm showing these 3 names?
Lithium-ion batteries. Yeah.
So they got Nobel Prize for the development of, or you can say pioneer of lithium-ion battery. See, this Whittingham and Goodenough, they started working on lithium-ion battery from 1970s and 1980s actually, and got Nobel Prize in 2019. So you never know when your work or your discovery can give you the best things in your life. So what they have done is they develop a cell with some cathode and anode, which the details, I'm not going to the details as you are from college or master students. So you can have cathode and anode and electrolyte. So this is the combination of this cell, and which can give you 2-volt working voltage. That is called lithium-ion battery. And first Whittingham started working on this, and then further development done by Goodenough. And Akira Yoshino actually first commercialized this lithium-ion battery. Now, I'll show you some pictures. These are the capacitor or battery in you can say early 90s, 20 and 30 in this time. So at that time, capacitor was a very big machine. So kind of it will take 3 feet by 4 feet kind of room to have this and working with it. So when you develop something, of course, the purpose was not the size reduction. Purpose was to your need, what you need, and what for you are developing the things. So now after this, when people work on supercapacitor, capacitor, so these are the things people after that try to reduce down the size. Now we have various kind of supercapacitor in the market. Many of you know. So these are the supercapacitor. It's a coin type. It can be cylindrical type. You can have laminate type. So all these kind of supercapacitor or battery available in the market. Now the size is it's not more than 1 centimeter cross 1 centimeter, or the radius is 1 centimeter. So it is very less. Even according to a need, you can reduce down the size. So very small. You can see in your hand wristwatch or toys, people are now using a supercapacitor battery that is very small in size, right? So slowly, when time progresses, people are developing, people are progressing, or advancement happens in the science and technology, so that based on the customer need, we can do the science, or you can say for the society, the societal need, you can do science. Nowadays, even in our lab, we do work on supercapacitor, and we are trying to do more thinner supercapacitor. You can say this is a thin and flexible supercapacitor. So what you see in the market, so we are actually one step ahead. We can the supercapacitor can be flexible, so that you can use in various electronic devices, and slowly people can also work on transparent supercapacitor or very thin film of supercapacitor. Okay. Now the thing is, when you do something, work on some science experiment, so first thing is your observation. Why you will be a scientist, so or you will be a researcher. The first qualification should be the observation. So you should have some observing power that something is happening. Okay, so for a simple who are not doing science, so for them sun is rising in the east and going to the west, set up to the west. But Galileo or other persons, so whoever discovered that, so they've observed that, or you can say Isaac Newton first observed that yeah, apple is falling down to the ground, but it was happening. But the observation power is important to discover the science based on some experimental observation, or you can propose some theory. Now nowadays, I mean, the basic science is known to you as you are from college students, so you know why the sky is blue, because of Rayleigh scattering, right? Or you can say why ocean is blue. So I'm not going to the details. I guess you all know. But so who discovered it, this Rayleigh scattering? Do you know who discovered it? The Indian physicist. who discovered Rayleigh scattering, and then one Indian physicist differed with the Rayleigh scattering in 1921, which is C.V. Raman. Okay, and after that he discovered Raman's scattering and got the Nobel Prize. Okay, so after Raman, so till now in science, so nobody got the Nobel Prize in basic science. So that again, so we have to think about this and work on this direction on basic science, so that in India we can also have a Nobel Prize. Another important things in nature we see, you see, in lotus leaf, all of you know, if you put a drop of water, so it do not wet, right? So why it does not wet? If you do water, so if you take other leaves or other things from nature, so the lotus leaf is different from them. Anybody have idea? Why it is so? So anyway, so that is because the lotus, nature created these leaves in such a way it is the property is it has hydrophobic property. And it has very small particle like things you can see here. So because of this, the leaf is hydrophobic in nature, and because of this, the water doesn't get wet. Now I'll show you based on this idea, based on nature. So scientists have created many materials which can show hydrophobic property, and that has different applications. Can you see the video? Can anybody answer? The video is
Yes, sir.
Yes,
sir.
we can see.
Yes, sir.
Yes, sir. It is visible.
okay. The right part is coated with some material, and the left part is as it is. So you can see. So this is totally hydrophobic. So he has taken two nails. One is coated with this material, hydrophobic material. Another is as it is. So you can see the wetness. So it doesn't get wet at all. Similarly, two gloves you have taken. One is coated with material, another is normal. Okay, so the thing is from inspiring from nature. So nature already had this property. So scientists can make or mimic the nature and can develop science and technology. So nowadays many materials are available which is hydrophobic in nature. So you can coat it according to your need, where you want your setup to be hydrophobic. So this is only one example of nanoscience and technology where you can use it properly. Okay. Now, what is nanoscience and nanotechnology? Why you used to call it nanoscience? Why it is different from others? So then you have to first know what is nano. What is so nano? You know the dimension is 10 to the power minus 9. So nanometer means 10 to the minus 9 meter. Now, in this range, if your material size or property falls in this range, then or if you have some material whose diameter fall between 1 to 100 nanometer, you can say. So you used to call them nanomaterials. Now you can make any material to nanomaterial if you can cut down or come into this region, right? So you can have nanomaterial. So it is very difficult to do this thing. So people generally use two approach. One is called top-down approach, another is called bottom-up approach. So top-down means you can have your material and can cut down and go to the nanometer range. That is called top-to-down. So top-down approach of synthesis of nanomaterial. Another is bottom-up approach. Bottom-up approach means you can synthesize it from atomic level. So the minimum sign is atomic level. So from atomic level, you can have some synthesis procedure so that the particle size will fall in this nanometer range, and you can have a nanomaterial. So the property of the nanomaterial is different from your bulk material. Okay, so that's why this field is this is a separate field which we call nanoscience. Okay. Now there are many instruments available in our institute. Also, we have many instruments where you can see whether you have this nanomaterial or not. Suppose you have synthesized or you thought that you have nanomaterial, but how to prove it? How to visualize it? How to see that this is the nanomaterial is formed? So this is kind of instrument. The name is transmission electron microscopy. So in this machine or instrument, if you put your material, you can see the size of the material. So this is one example I've given you. This is a gold nanoparticle. Okay. So the size is here. You can see this mass is 2 nanometer. Means the size of this sphere particle, you can say 10 to 15 nanometer. Okay. Means this is your 1 nanoparticle. And you can visualize it under this transmission electron microscope. This is called electron microscope. Okay. So likewise, there are several things, several instruments available nowadays where you can not only nanoparticle, you can actually see the atoms. So here in this bottom panel, you can see all are actually atoms. These are atoms. Atoms are arranged to form a nanoparticle. Okay. Now, another one example of nanoscience and nanotechnology, and to show. So all of you know. So what is this? This is in Harry Potter movie. So it's to show this magic. So it is vanished. Of course, they have used this technique as a magic, but science is there behind it. Okay. So it's called metamaterial. That is a kind of material. It's called metamaterial. So if you have your cloth or any object which is made up of metamaterial, so the property of metamaterial is in case of metamaterial, if light falls, so light is actually will not go. We know the light go straight in the straight direction, right? But because the property of material, light will bend and go in the different direction, and in such a way that the cloth or the object will be invisible, or it will, you can say it will be transparent, so you can see through the object. This is the property of metamaterial, and you can use it excuse me, and you can use it to show this kind of magic. So everywhere science is there, the thing is where you will use it or how to use it. Okay. Now another one example also, the phenomena is called electrochemiluminescence. What you can see, the first one is fireflies. Okay. Second one is jellyfish, and the third one is glow stick. So three different objects I have taken from three different places, you can say. But what is the link between these three? The link is their phenomena. All three glow, and why they glow? The linkage is chemiluminescence. So they have some material which actually absorb energy and produce light. And that light we see in different form, and the phenomena is common, which is called chemiluminescence. So again, so we know what is fireflies, we know what is jellyfish, and we have used glow stick in different parties on different places. But the science is they are the same phenomena because of we see light. Now I'll come to a little bit different direction. So what I'll show here is the application of nanoscience and nanotechnology in different field. So in our society, the major challenges is actually energy, environment, security, food, and disease control. And all these aspects, so nanoscience and nanotechnology is playing a major role, and they are using nanomaterials in all three different aspects in nowadays. So I'll start with energy. Mainly, I'll focus on energy only. So in energy, you know, energy is there in three forms. One, we can generate energy, we can store energy, and we can consume energy consumption. So, you know, the energy generation, all of you know that nowadays people are concerned about renewable energy generation. And then we used to store it. We can store it in supercapacitor battery. And finally, at the end of the day, in our house or everywhere, we are using it. So now the thing is how we can generate energy in renewable way. So one thing is in so sunlight is there is no end. So we can use sunlight and can harvest energy and can use it in different form. Okay. So this diagram will tell you. So using solar cell, you can generate energy. You can use it either in the supercapacitor bank or battery bank, and then finally. So this the whole thing is called energy cycle. Now people are working on all three different aspects: how to improve the supercapacitor or battery, how to generate more electricity throughout the day or a different time to generate more electricity, and how to use it. So I'll give you a few examples in advanced form. So now people have moved forward from this. This is a very recent development where you can see bendable electronics. So solar cell, we can what we see is not bendable, but nowadays people have developed bendable solar cell, bendable watch, bendable lot of electronics, even mobile phone and other things is also bendable. So Samsung, LG, they have recently developed and marketed bendable mobile phone. Actually, you can use it as a wristwatch whenever you need, or otherwise it is bendable. So to make this thing bendable, you have to consider each and every part of the mobile should be flexible. So all the electronics component should be flexible. Then only it will be bendable, right? So your battery part, your capacitor part, your other component, all the electronics part should be flexible. So already research and development are there. Few companies already launched. So they are trying to make it more flexible or more thinner. This is the bendable phone by Samsung. So they have actually used flexible graphene film. So graphene is another material which is transparent as well as flexible. So they have used this graphene in their skin so that it is flexible. This is just for your information, so that as you are in master and bachelor, so now in next step you will be interested in research. So in which direction you should go, what is your curiosity, what is your motivation? So these are the actually motivation to do something in your future. So in our group, I'll briefly tell you what we are doing. So in our group, we are working on supercapacitor and battery based on electrochemistry. So we have recently developed graphene like material what I have shown in the last slide from peanut cell waste. So this is kind of waste to wealth, or you can say waste to energy material. So we are working with some company to do it in large scale. This is from Tamil Nadu. Some company approaches us and it has several news coverage. Then we are working on a different kind of flexible supercapacitor, wire-based supercapacitor. You can see here we have shown. So wire-based supercapacitor, we can use one copper wire and modify it with your material, and can and this capacitor can glow one LED for a long time. So another one direction we have explored. So we have used another waste material which is called fish gill. And from this, we developed a metal air battery, another kind of battery, which is zinc air battery. So again, the waste to energy in this direction we're working, and we're trying to do it in large scale so that we can commercialize it. So why we need to develop this thing? Because our purpose is actually to develop something which is fully renewable. And if you can use some waste material which is otherwise no use, right? That's why it is waste material. So if we can use this waste material and can develop something value-added material, our purpose is to work on first on energy storage material, on supercapacitor or battery, then on hydrogen generation. So you can use this type of material for hydrogen generation. So you can actually split water. Then water, will produce hydrogen and oxygen, and then hydrogen you can use it as a fuel, so that your dream will be successful. So what is the dream? So car can run by water. How car will run by water? You don't need diesel or petrol or any other fuel if we succeed on this thing. So this is a design, or you can say our dream. What we'll do, we'll have one water electrolyzer, where you'll have water, so that will dissociate to produce hydrogen, and that hydrogen is your fuel, which will run by the car. But it's not that simple. What you need you need another battery which will actually help to dissociate the water. And how this battery will charge? That will be charged by solar cell, and which you can keep in your roof of the car. So this is, but this is in the diagram what I have shown you in very simple way, but it is not that simple. So each and every component you have to work and show how much efficiency you are getting, what is the problem. So a lot of things is going on. But if you have dream, you can get success in one day, today or 20 years later. Okay. Now I'll show you very quickly in this direction, in supercapacitor, battery, and solar cell, what are the recent development there in worldwide scenario. So supercapacitor, you can use it in many aspects, like for high power pulses, hybrid vehicles, renewable energy system. And not only that, nowadays people are using solar cell supercapacitor combination in solar boat and different buses. So I'll give you another few example. People are using supercapacitor cloth actually. So you can have your thread coated with some material, and you can make some smart garments. Why you need it? Because if you have your device in your garments, so when you do the morning walk or something, you can monitor your devices, like blood pressure measurement, a lot of things you can use it. So you don't have to go to the medical shop or some hospital to do all these things. So you can have it in your own, and your cloth actually embedded into the cloth. This is called smart garments, and you can use it. So nowadays people are using hybrid car, and few companies are actually trying to make the super car body to convert it to supercapacitor, so that you can reduce your car weight, and you can increase the efficiency of the car. So this is a kind of hybrid car. The research actually is going on in this direction, so that you can make your car body to convert it to the supercapacitor, and you can use it. So few example already is in the market. So this is from Taiwan. So they are running train using supercapacitor. So you can see there is no wire. So you don't need any electricity. So what you needed, they have a solar cell in the rooftop and supercapacitor somewhere else. So it can charge by solar cell. But if sunlight is not available, they have power station, charging station in each station, and it takes 20 seconds to charge this supercapacitor. Can you see 20 seconds only? So car, I mean, 10 will stop in each station minimum 1 minute, right? So by the time you can have, you can charge your supercapacitor. Not only that, in France also they are running, although you can see the wire, but they few part is not still developed, but this is running by supercapacitor only. Okay. So I'll skip this one. So with this, I'll stop. So this is one book we have written on carbonaceous metal for future energy. You can have, it is available in Amazon or Flipkart, so you can have it. So we, with this quote, I'll stop. So what Abdul Kalam is to say, so always think positive, and fail means it is not fail, it's actually attempt to learning, and end is not the end. In fact, end means effort never dies. So no means is your next opportunity. So believe in that and think big, think, do the time management, take proper action at the right time, take proper decision at the right time, so that you'll get success in your life. And think big, always think big and dream big. With this, thank you all of you for your patience, and you can have question, you can ask me or write.
Yeah, thank you so much, sir. Thank you so much for the very informative talk. It was amazing to learn about supercapacitor from past to present and their outlook in the future. Before moving to the Q&A section, I request Mr. Yatin to kindly share the feedback form of today's event. And let me tell you, it is mandatory for all the registered participants to fill out this form to get certificates at the end of this program. Now, I would like to request the audience, if anyone wants to ask the questions from Dr. Day directly, please turn on your mic. You can also put your question in the chat box.
So we have a question from Muzaffar Ahmed. He asked what leads to change in properties of a material when we go down to nanoscale. What is the science behind this change?
Yeah, this is very good question. So see, when you are going or you are reducing the size of a material, so what will happen? Suppose you have the server, when the size is very small, there are many properties actually change. When all the properties, the optical property, their electrical property, their mechanical property, all their property will change. And because of that, so you will, and not only that, your surface area, main thing is your surface area. Suppose you have a ball, you can consider a ball with 1 meter in diameter. Now you have a ball with 1 centimeter diameter. So you can consider how many ball you can make from 1 meter diameter ball to 1 centimeter diameter ball, and you can measure their surface area by. So you will see the surface area of the smaller ball will be larger than the bigger ball. So that will give you an idea when you are coming from bulk to nanomaterial, your one property, the surface area will change. Not only that, because of that, your optical property will appear, electrical property will change, a lot of property will change. And that's why they are different from their bulk counterpart. I think I gave your answer.
Thank you, sir. Yeah, there is another question in the chat box. The question is, how can we synthesize nanomaterials synthetically by top-down method?
Okay, top-down method, I mean, there are different methods are available. I mean, may I know, I mean, what you are doing so that I can have your answer? Are you bachelor student or master student?
Yeah, Alok, you can turn on your mic.
Master
His
students. Okay,
master
yeah, I
student.
can see that. So see, one example I can give you. Do you know graphite? So graphite is one material, and the nanomaterial you can say graphene. Okay, so graphite is your bulk material, and nanomaterial is graphene. I'm taking this example so that it will be more clear to you. Now, graphite to graphene, there is a top-down method is available. So that is called chemical method, which is called you can take graphite and mixed with some reagents, for example, sulfuric acid, potassium permanganate, some oxidizing agent, so that you can exfoliate graphite. You know, this is a layer structure, so you have many layer material, so that you need to exfoliate. I mean, you have to separate one layer to another to have your nanomaterial. This is one example. Another example I can give you, gold. So you see, gold in bulk form it is available. Now you have to work with, I mean, you have to take some chemical which can convert this bulk gold to nano gold. So there is a method, different method available to do that actually. So it's actually depends on which materials you are taking. So method is not standardized, or it's not common for all. So depending on what material you are taking, so you can have different top-down method available.
Thank you, sir, for the answer. There is another question, I think, from R.K. Trivarshini. Yeah, please go ahead.
Good afternoon, sir. Actually, my question is that why should one rely upon these batteries and supercapacitors, as many material scientists are working on many storage materials like ammonia, boron, or MOFs, or any catalyst they are developing, and they are working on some alternatives. Why should we focus on this the supercapacitors and batteries over the materials that are available?
Okay, so see, the thing is, you want to always improve its property, right? So although there are battery and supercapacitor are available in the market, but you are not satisfied with that. Suppose if you take one example, so a few years ago, some Samsung battery used to burst or used to overcharge. I mean, heat it, right? So the part, and suppose you are purchasing a mobile, and they are advertising that your mobile charge will retain for example 18 hours, and another company has come which will show you you can have once you charge, so it will be for 4 days. So which one you will purchase if the cost is same? Of course you will go for the which one will give you 4 days charging, right? Means you have to improve the property of the material so the device performance will improve. We are always we are always hungry actually, we need more and more. So that is the main purpose that people are working to develop some better material so that you will have better property in the devices.
Thank you, sir.
Thank you, sir. There's another question from Deepak Mishra. He's asking, what is the future of sodium-based energy storage devices like sodium-based polymer electrolytes?
Sodium-based polymer electrolyte. Sodium-based energy storage devices is different, and sodium-based polymer electrolyte is different. I mean, which one is your question? Sodium-based devices mean we'll consider sodium and battery, sodium and capacitor, all this thing. And sodium-based electrolyte is something different. May I know which one is your question?
Yeah, Deepak, may I know? You can type in the chat box, or you can turn on your mic. Sodium-based energy storage devices.
Yeah, sodium-based energy storage devices means sodium-ion battery. So actually, people, researchers are moving towards this direction. This is there is a very good prospect, because see, in case of lithium and battery, you know, in India we don't have lithium and source actually. So we are purchasing lithium, and not only that, from the safety aspect also, lithium is not that good. So people are moving towards sodium and battery, or sodium and energy storage system. So there is a very good prospect on that. You will see, I mean, already few countries already developed sodium and battery. In India also, many people are working on. So in the next 5 years or 10 years, I hope that sodium and battery will be available in the market. So there is a huge prospect on this direction.
Thank you, sir. There's another question from Saket Pal. Can we get more good result with electrochemical supercapacitor with a battery joint system?
Yeah, I mean, as I told, I mean, always we will try to improve the property. So in hybrid car, people are actually using this system. So there is an advantage and disadvantage in case of both capacitor and battery. So if you so the thing is energy and power density. So one has high energy density, another one has high power density. So if you can join them, people are trying to do that in case of hybrid battery systems so that they have both the property of supercapacitor and property of battery. So in this direction, research is going on.
Thank you, sir. Shailendra Chauhan is asking how the nano size can be achieved with specific surfactant combination with the lipid carrier. Is there any novel approach?
There are many novel approach. How the question is how that is a very long time I will take if I explain. But you can see I can briefly answer this question. So not only this lipid or other things. So when you do the nanoparticle synthesis, you need two things. One is reducing agent. If you go by bottom-up approach, so you have to take some metal salt or something. For example, if you want to do metal nanoparticle synthesis, so then you have to reduce it. But the problem is once you reduce it, it may again go to the bulk form. So you need to stabilize it. So when they are started reducing, so their size is very less. And if they have some capping agent, it's called capping agent or stabilizing agent, so that this small particle will be stabilized under the circumstances. And that's why you need some lipid or surfactant, all these things to stabilize the nanoparticle. That is the chemistry.
Thank you, sir. There is a question from Namit Singh. How would you make nanomaterials tensile strength greater for industrial use?
Nanomaterial? I didn't get the question.
Nanomaterial tensile or tensile strength greater for industrial use.
Tensile strength of nanomaterial. The question is not actually clear to me.
Namit, can you turn on your mic and rephrase your question? Okay, maybe we can come back to that later. There is another question from Akshay. He's saying, as you have discussed a few application of supercapacitor on water splitting and H2 generation, so can you please put some comment on linkage of carbon sequestration with electrochemical?
Yes, carbon sequestration,
yeah.
So actually, in case of hydrogen generation, what you need is catalyst. So one catalyst can it's called electrocatalyst. So if you use that catalyst, so that catalyst is actually break the water to produce your hydrogen and oxygen. So there is no link of carbon sequestration with it. So carbon sequestration, what it is, you have to reduce the carbon content in different way. But the catalyst might be same in both the cases. You can use the similar. Nowadays, people are trying to do. So they are trying to do some catalyst which can actually have this property to absorb carbon dioxide and can finally reduce it to other form. So they are in this direction. Work is actually going on. And this is actually our future goal, you can say, in this direction.
Okay, sir. Thank you for the answer. We have a question from Saket Das. I have a question in general interest about science and research. What do you think about current scenario about research? Don't we need more sustainability and recyclability, especially for the materials we are using? Sorry.
Yeah, so you want to mean you want to work on more recyclability or sustainability? Yeah, of course, you are right.
Yeah.
In this direction, we should do research, and we are actually doing. People are doing. That's why we are going towards renewable energy, right? But you see, the basic research is always important. One can think about recyclability, regenerability, all these things, but and there also you need some basic research. If you want to reuse your material, so what is the property which will help you to reuse the material? If it is not reusable, what are the modifications you need to do in order to have the reusability? They are also need basic science. So without having basic science, you cannot do anything. So yeah, of course, one should think about reusability and recyclability and renewability.
Okay. Thank you, sir. There's a question from Satya Brata Manna. How we can apply nanotechnology in solar energy, and is it possible to generate more power in future?
Yeah, people are doing that. So in case of solar energy, all the solar material people what you are using, all are nanomaterial only. So nowadays, titanium oxide, many silicon, so all are nanomaterials only. So people are using nanomaterial for to making the solar cell, and more power is possible. It's coming up day by day. Performance are increasing. Nowadays, efficiency, I mean, from 10% to people achieved already 30% efficiency from solar to energy conversion. So huge research is actually going on in this direction.
Okay, sir. So I think if you guys have more questions, we can directly contact if Sir Dr. Day agrees.
Yes.
Like you can contact them via mail. And let's move towards the conclusion part. So on the behalf of the organizing committee, once again, I thank you very much, Dr. Day, for honoring us with your presence. We are looking forward to seeing you in person sometime in the near future. So before concluding the lecture, I would like to request one and all present here to kindly switch on their camera so that we can have an image of this event.
No.
Please turn on. Almost. Thank you. Now I would like to extend my sincere thanks to the participants for their presence in the first lecture of the Teach for Science event organized by Prayas with INYAS. The next lecture will be on the same day at the same time. So see you next Saturday and have a nice day. And thank you, sir, for the informative talk.
Thank you all. Nice.
Thank you, sir. Thank you, sir. Thank you, sir.
Thank you, sir. Take care.